Hey everyone, long time no see. Today we'll dive deeper into using peripherals. This episode revisits how to light up an LED using C++, and how to handle button inputs. The components needed are shown in the image above, an LED and a button. Quick tip, my LED has a higher voltage rating, so I connected it directly to the OrangePi. Don't try this at home. I'll add a resistor in series. Why switch to C++? Because testing showed C++ is actually a bit more practical than Python. This video uses some new software and tools, like VS Code and CMake. If you haven't installed VS Code yet, check out episode 3 on system setup. Installing VS Code is similar to installing QQ or PyTorch. Find the corresponding ARM64 deb package on the official website. The rest of the steps are pretty much the same. Now let's see how to install CMake. In the extensions manager on the left, search for CMake. Then download both CMake and CMake tools. Then enter this command in the terminal. To install CMake into your terminal environment. After installation, let's briefly introduce CMake. First, create a file named cmakelist.txt. In this file, the first line sets the minimum CMake version requirement. The CMake we installed should be higher than this version, so you can ignore this line. Next, the second line specifies the project name. Here, the name is LED_test. Modify this according to your project. Since the official OrangePi image typically includes the wiring library, using the find_library command will automatically search for installed libraries, locate its path, and assign it to this variable. The fourth line compiles our main program into an executable named LED_test. The final line links the wiring pi path to the executable file LED_test. Now let's examine this main program for lighting the LED. It begins by importing the required libraries. It's worth noting that, when defining pin macros here, the pin numbers used correspond to those in OrangePi. My board is a 5+. You can refer to your manual, or use this command to check. You'll find pin 5 in OrangePi corresponds to pin 11. On the board, it's the 6th pin from the top, circled here. We'll connect the wire to this pin later. The code below is quite straightforward. It initializes the pin, checks if initialization succeeded, configures the pin as output mode, and cycles between high and low levels in a loop. Now, let's focus on using CMake. First, enter this command in the terminal, and press enter to run it. Both S and B must be uppercase. This command creates a CMake build directory in the current working directory. Next, enter this command to compile and build the build directory. You'll then notice a build directory appears on the left, containing numerous files. If you wish to test my code, and haven't deleted this build directory, you must rebuild it yourself. Otherwise, environment incompatibilities may occur. How do we run it after compilation? We need to enter this command sequence in the terminal. This command is the path to our executable program LED_test. Remember to prefix it with sudo. Notice here I forgot it, causing an error. Controlling GPIO requires root privileges. Then we can connect the wires and observe the LED lighting effect. As seen, it works without issues. To exit the program, press Ctrl+C. Next, let's examine the second code. The second code handles keypress control of the LED. Here we implement modular programming, so we created an include folder to store .h files. The src folder holds cpp files. In this code, the button is defined on pin 7 of the wiring, which corresponds to pin 13 on the board. We then define a key_number variable to control its state. Below, the key_init function initializes our button, setting it to input mode with internal pull-up resistors. Next, we set up a key function to detect the button's state. When the button is pressed, the pin is pulled low to a logic level 0. Key_number is assigned the value 0. When no key is pressed, the pin remains at a logic level high, which is 1. At this point, key_number is assigned the value 1. This section declares two functions in the header file. Now let's examine the main program. First, the LED pin is defined, still pin number 5. Then the key_number variable from the previous code is externally called. Next, the LED and button pins are initialized, simultaneously checking if initialization succeeded. Here, the key function is first called, printing the current high/low voltage of the button. And based on the key_number value, controlling the LED's on/off state. Finally, looking at the CMakeLists file, we can see the project name has changed to key_test. Then, since we added header files, we need to include the path to our header files and link them. At the same time, we have multiple CPP files, so we use the set command to bundle these two CPP files, collectively named sources, then packaged into key_test. This executable file, finally, link the OrangePi library. Now, we navigate to this directory. Similarly, we first create a build directory. Then we compile. Finally, we run it. Here, the current pin level is printed on the screen. We can see it's 1, high level. Now, when we press the button, we see it changes to 0. The actual effect is like this. When we press the button, the light turns off.